I'm sitting on the dock of the bay, watching the tide roll away.
Hey there, I'm Josh Clark, and in this Brain Stuff, I explain to you how the tides work. Have you ever seen somebody buried up to their neck in sand on the beach, and then the tide slowly comes in and they drown, and wondered, I wonder how tides work? Well, next time, you'll know, and you can explain it to that person as they wait to die. We need to be very careful here, because as French astronomer Francois Arago once said, studying the tides is the tomb of human curiosity, which means it can break your brain, as you'll see. There's a lot of factors involved in creating the tides here on Earth, but the big three are the moon, the sun, and the Earth. The gravitational pull of all three of those bodies interacting creates the tides. The biggest factor actually is the moon. It exerts about 2.2 times more power on the tides than the sun does. So for once, the moon gets to one-up the sun. It's kind of a big deal to it. Imagine for our purposes the Earth is right here and the moon is directly above it. Now, they exert a gravitational pull on one another, and since on the Earth most things are pinned down, we have shoes, buildings have foundations, stuff stays in place. But the oceans, being literally fluid, actually can be pulled toward the moon, and this is what creates the tide. The moon's here, it's pulling on the ocean at the top of the Earth, creating a high tide on the top. Now on the bottom, another high tide is created because the Earth itself is pulled toward the moon, even though the oceans down here have less gravitational pull exerted on them, being farthest away from the moon. So on the top and bottom, you have high tide because of the tidal bulges, and on the sides that are at right angles to the moon, you have low tide because the ocean's stretched thin over the surface of the Earth. Pretty crazy, huh? So, like I said, the sun also exerts an influence on the tides, but it's less pronounced than the moon's. See, it actually enhances or diminishes the gravitational pull of the moon here on Earth. When the sun and the moon are in alignment, the sun enhances the moon's gravitational pull, creating higher tides than normal. They're called spring tides, and they happen on a full moon or a new moon. Now, when the sun and the moon are at right angles to one another, with the Earth right about here, the sun diminishes the gravitational pull of the moon on Earth, creating lower than normal high tides, also called neap tides. These happen on the quarter moons. Because the Earth and the moon are constantly moving and moving around one another, there's a constant movement from high tide to low tide. Twice a day, you get a high tide in most places, usually once every 12 hours and 25 minutes. But this can vary, and some places only see a high tide once every 24 hours. Those are called diurnal tides. So this is a daily occurrence, actually twice daily in most places. But tidal waves, even though they have the word tide in them pretty much, but without the E, they're not related to this gravitational push and pull. They're usually the result of earthquakes. So that's tides. Hopefully we avoided that tomb of human curiosity and you guys get it. If not, going back and watching it again, there's no shame in that. It's pretty heavy stuff. If you like this video, let us know. Leave us a comment below, and hey, subscribe. Why not?
Hey guys, Mr. B here, and I hope you enjoyed that brief overview of tides. We're going to go into a little more detail and answer the essential question in your WICS today. As we finish up this final WICS and the sun, moon phases, and tides unit. So let's just jump right in there and get to work. Before we answer that first essential question, what affects the tides on the Earth, I think it's important to know what tides are. And somewhere on your WICS, maybe up at the top there where there's some white space, you need to write the definition. Tides are the daily fluctuation in sea level. And that's how we define tides. And you'll notice that what I mean by fluctuation is change. In the picture here, you'll notice that here you have the water level that's up close to these people and this truck here. Look at the rocks, the position of the water in relation to the rocks. And then over here in the low tide, you'll notice you don't see the truck anymore, but you see the rocks there and how the sea level has The water level has backed up, it's gone down, and it's not as high. And that's the fluctuation we're talking about, high tides versus low tides. Now, what affects these tides? What causes high tides? What causes low tides? And this is your first essential question that you need to answer. And I think there are three things that we need to write down as we talk about what causes tides. And the most important thing is that tides are caused by the gravitational effect of the sun and the moon. That's what causes tides. Now, I think it's important to note also that the moon's gravity has a larger effect on tides, not because it has more gravity. In fact, the sun has tons more gravity than the moon because it's larger. However, the moon is closer, and because the moon is so close to our planet, its gravity has more effect on our ocean's tides than the sun does. Although the sun does affect it, and we'll see that more in a moment. I think it's also important to note that there are two high tides and two low tides typically in a 24-hour period. You kind of see that as it is written on this diagram, that you have two positions of high tides and low tides. Okay, so now let's talk about that position. Let's talk about how position of the sun, earth, and moon affect tides. And as in this diagram, you'll notice that the high tides occur in those places on the planet that are in line with the moon, because the gravity of the moon is pulling on them, and that the low tides occur in those places that are not in line with the moon, that are at a right angle. We can see it more clearly in this diagram as we talk about the effect of the position of the earth, moon, and sun. The brown sphere represents the solid earth, and the blue represents the ocean. The tidal bulges are those places of high tide that occur that are in line with the moon or being affected by its gravity, and the low tide would be, again, those places that are not in line with the moon. And it creates a tidal range, like on that beach that we saw in the very first picture. You have these low tides will be represented by this sea level, and then the high tides would be represented by this higher sea level. And that's the effect of that position. Now, if it were me, you can write that down, what I just said, or maybe take a moment and just draw this diagram. I think it probably answers that question even better than words. The diagram really does a good job of answering that question, how the position of the sun, earth, and moon affect tides. Now, the sun does come into play, especially when we talk about spring and neap tides, and this is your third essential question. And we need to talk about how their alignment affects our ocean's tides, and what we call spring and neap tides. And we're going to talk about the difference here. You'll notice that a spring tide occurs when the moon, the earth, and the sun are all in a line. When the moon, the earth, and the sun are all in a line. It's what we call a spring tide. And because the moon's gravity and the sun's gravity are working together, so you have the sun's gravity plus the moon's gravity pulling on the tides, and they're working together, you get really, really high tides. And the low tides are also extreme. So you have extreme high tides and extreme low tides during a spring tide. So you have larger tidal ranges. Your high tide and your low tide are further apart. And in a spring tide, the moon, sun, and earth again are all in line. Now, what moons would you see in a spring tide and a low tide? Well, because they're all in a line, if the moon is located between the earth and the sun, you would see a new moon. If the moon is on the opposite side of the sun, then you would see a full moon. So that's the moon phases that you would see. So there's the spring tide, and you should write that down, so that you know the difference. Now, neap tide is completely the opposite. The neap tide, you have smaller tidal ranges. Your high tides are still going to be in line with the moon, as I said earlier. High tides are always in line with the moon because the sun's gravity doesn't have as much effect. But because the sun's gravity is pulling on the oceans in this alignment, it decreases the high tide associated with the moon's gravity. So your low tides, which would be located here and here, are going to be not as low, and your high tides, which are here and here in line with the moon, are not going to be as high. So your tidal range is smaller. And you'll notice that the alignment is a 90-degree angle. You have your moon, your earth, and your sun, it kind of makes an L, or what we call a 90-degree or right angle. Now, the moon phases that are associated with the neap tide are going to be your third quarter and your first quarter, because it's the third quarter and the first quarter, they form that that L, or that 90-degree angle. So now, in your action item today, that's the difference. I'm sorry, let me back up. That's the difference between the neap tide and the spring tide. And again, you probably underneath that question need to write these three details for both of them. And in your action item, you're actually going to draw the diagram. And so let's just get to your action item. Oh, I almost forgot. Here's we were talking about the difference between the spring tide and the neap tide, and the spring tides have the larger tidal range and the neap tides have the smaller tidal range. Well, this is the Bay of Fundy. It's a place on the earth that when there's spring tides, the tidal range is so great. And there's several images here you can see between the high and the low that show you the difference between the high and the low tides in a spring tide scenario. And so here you're looking at the same picture. Here's the boats in this picture that are in water, and the water has receded all the way out of the bay, and so the bay, you can literally see the land in the bay here. Here's another picture of that same Bay of Fundy, and another one over here. And so you can, like I said, in that spring tide, there is such a difference between your high tide and your low tide, and not so much of a difference in the neap tide. The high tides aren't as high and the low tides aren't as low. But you can see how let's see the dock here. You can see how the water has really gone down. Okay, so now let's get to your action item. Oh man, I'm sorry, we're not ready for your action item. I also need to mention tidal graphs. One of the things you're going to do, and this is going to help you with an assignment. You don't have to write anything down, but you need to know that you need to be able to look at a tidal graph and understand what it's telling you. A tidal graph shows the change in tidal ranges over time. You'll notice that on this tidal graph, there are 2 high tides and 2 low tides, like we said, in a 24-hour period, right? So here's your first high tide in hour 0, and here is your second high tide in hour 12. And as you get closer to that 24th hour, you're eking back up to the high tide, which would be in the next day. Then you have your 2 low tides here. So tidal graph just shows that fluctuation. Now you can use tidal graphs to actually determine the moon phases. Here you have, let me just explain the graph. Here is the high tides, and then you go down to the bottom of this, and this would be your low tides. Now here's what I want you to see. Look at the moon phases. Here's a new moon, right? Look at the difference between your high tide and your low tide, right? Over here you have this is the new moon. Look at your full moon. Again, look at the difference between your high tide and your low tide. It's really a huge range. Now in your first quarter and third quarter, you'll notice here's your high tide. You still have a high tide, you still have a low tide, but the difference between the two is much less. So again, you can determine moon phases and notice where your high tides and low tides are as you look at these new full moons, first and third quarters. Now finally, we're going to get to the action item. And the action item is simply to do this, to draw and illustrate, label the position of the sun, earth, and moon during a neap tide and a spring tide. And you can do this on the back of your wicks. Hint, don't forget, a few minutes ago there was a diagram of the spring and the neap tides in this video. Okay, that's it for this this Wix. I hope you've got your essential questions answered, and we'll see you in class.
I'm sitting on the dock of the bay, watching the tide roll.